Good afternoon, ladies and gentlemen. Welcome to E.S.A 2022 warm-up, the online technical conference preparing to E.S.A fourth edition. First of all, let me thank you all for coming here today. Let me introduce myself. I'm Virginia, one of VALVEcampus organizers. The topic of today's presentation is the development of an up-to-date quality standard for gland pickings. The last minutes of presentation will be the question and answer part. Please write your question in the chat box. It's now my pleasure to present Ralf Vogel, Technical Director at the European Sealing Association. Thank you so much and have a good presentation. Ralf, you can start.
Good afternoon, ladies and gentlemen. I'd like to welcome you to another paper at the Industrial Valve Summit. This presentation, called Development of an Up-to-Date Quality Standard for Gland Packings, was created by my fellow Technical Director at the European Sealing Association, David Edmund Scott, and myself. Some biographical information about myself. My name is Ralf Vogel. I'm a mechanical engineer, and I've been working now for over 26 years in the sealing industry. Currently, I'm the full-time technical director of the European Sealing Association. Before, I worked as Group R&D and Engineering Manager for Vogel Packings GmbH. Here, basically, my main tasks were R&D of packings and gaskets, as well as application engineering, including also fugitive emission solutions. I worked quite a lot with also with end users and valve OEMs on application engineering problems and gained quite a lot of experience solving problem cases. Some information about the European Sealing Association. The European Sealing Association is a trading organization of European-based companies which manufacture fluid sealing devices. It has been established in 1999 and is registered in the UK and Germany. The main sealing groups we represent are mechanical seals, packings, gaskets, elastomeric and polymeric seals, and expansion joints. The E.S.A has around 50 members, including also research organizations and universities. We also work quite closely together with a similar organization in the US, the Fluid Sealing Association, which represents all the sealing manufacturers in the Americas. Fugitive emission performance and long service life are key requirements for modern braided gland packings. But when deciding which packing to select, there is no overall recognized standard to define the quality of the packing and the material used in the packing. There are some emission performance standards like API 602 or company-related standards like Shell MESC 85-204, but they define only specific performance requirements. The quality of a packing and its materials can guarantee a long service life and a good performance. But by saving on the seal costs, some low-cost materials might not meet a certain quality standards and are likely to fail prematurely or suddenly. In this case, quite significant costs can arise due to product loss or downtime, as seen in the pyramid in the picture here. Also, other related costs like environmental or legal costs in case of personal injury or environmental damage can be quite high. There's an old British standard in existence to define quality aspects of a packing material. It is BS 4371 from 1999. But this standard has not been maintained, is now very outdated, and it does not include modern packing materials. It even still describes asbestos materials which have been long banned in the European Union. The members of the Packings Division of the European Sealing Association and the Fluid Sealing Association have developed an up-to-date specification for gland packings, defining good material specification. In the following, I will give you more details about this new standard. A specification for gland packings manufactured from yarns and ribbon has been developed by the E.S.A. and the F.S.A. over the last 3 years. Now the final draft for the packing material standard has been approved, and this specification provides a method of describing the materials, the impregnates and lubricants for various types of yarn and ribbon-based packings intended for use as gland seals in mechanical equipment such as pumps and valves. In the first part of the specification, the yarn groups and materials are defined. There are 6 categories, including natural yarns, glass, ceramic, synthetic, PTFE, and carbonaceous yarns. In the group, the most common materials are listed and they are given a yarn code for identification. So, for instance, in the natural yarn group, there are rummy, cotton, flax, hemp. In the glass and ceramic group, there's glass, ceramic yarns, and mica. In the synthetic fiber group, there are para-aramid, meta-aramid, acrylic, polyamide, novoluid, PPS, and PBI yarns. The PTFE group contains PTFE filament yarns, as well as ePTFE, ePTFE graphited, ePTFE graphited and oil, as well as ePTFE filled with talc and oil. The last group is the carbonaceous material. There we find the pre-ox pen yarns, as well as the carbon and graphite based yarns, and the expanded graphite yarns. In the next material group, the typical impregnants and lubricants used in packings are listed in a separate table, and they also receive an associated code. It can be basically that there's packings using no additional impregnant or lubricant, but the main ingredients added into a packing are PTFE, mineral grease or oil, silicon grease and oil, graphite and mica as impregnants or lubricants. Additionally, the packing or the packing material can be also reinforced, and also for the type of reinforcement there's a separate table listed and coded again. So there can be no reinforcement, or glass, cotton, carbon, PTFE filaments, stainless steels, or Inconel can be used to reinforce the packing material. Important characteristics for the good quality packing yarn are the tensile strength and the elongation at break values. In the standard, the table has been defined with minimum values here with the help of yarn manufacturers to make sure that the packing yarns will perform and that the packing can be produced and braided without any problems, as well as guarantee that the packing will perform in the application under elevated temperatures as well as pressures. Another quality criterion for packing yarns is the shrinkage value, especially at elevated temperatures. A table here has been also created with the help of manufacturers to show certain shrinkage values or maximum shrinkage values in air at elevated temperatures. Especially, for example, low quality PTFE yarns not properly pre-stretched can show significant shrinkage and failure in service due to extrusion and related high gland pressure losses, but also with other materials which show high shrinkage problems can occur and the service life will be shortened. Another quality criterion for packing performance is the creep relaxation under gland pressure. Unfortunately, for specific packings or packing materials, there was no specific creep relaxation values available. So the packing division decided to run their own test, and one of our members is the company Impregnates Service, who's specializing on testing of packings, gaskets, as well as valves. So we set up a test, and 16 of the most commonly used packing materials were defined and provided by different E.S.A. members. The creep resistance of a single packing ring was established under an initial load of 25 MPa. The test duration and the holding time was 4 hours at room temperature. In the graph here you can see one of the test results. So the packing was submitted to the 25 MPa, then there was a short holding time, and then it was retightened to 25 again, and then the relaxation or the gland pressure loss over 4 hours was measured. And also after finishing the test and when the rings were extracted, the extrusion was checked. Based on the test results, a minimum creep relaxation values have been determined and put into a table, which you see here on the right hand side. The table shows the different packing types that have been tested. We start with rummy, PTFE and all, cotton grease packings, para-aramid and meta-aramid, both with PTFE and oil impregnation, acrylic, PTFE and oil, polyamide, PTFE and oil, novorid, PTFE impregnated, PTFE filament packing with a PTFE impregnated dispersion, ePTFE, and the different type of ePTFEs, graphite with oil, and talc and oil, and then the carbon-based packings like Preox pen with graphite PTFE impregnation, carbon filament with graphite impregnation, graphite filament, graphite impregnation, and expanded graphite reinforced with Inconel. You see the difference here in the creep values for the typical pump packings who contain a grease or lubricant as a running in lubricant. These values are quite low because again the oil will run out under pressure, which is intended for pump packings to counteract the heat dissipation. For the valve packings we have significant higher values, which really starts for PTFE with creep values bigger than 75, or for carbon filament values bigger than 80%, and with expanded graphite reinforced with Inconel we have values that's even bigger than 90%. Besides the specific values that have been shown in the previous slides, other criteria are also defined in the guideline. For example, for the pump packings, again, the grease, oil or binder content, because this shouldn't be too high, because again, a high amount of grease, oil and binder will give a quite high creep relaxation or volume loss, and the packing won't last that long in the application. Then again, the dimension and tolerances are defined that a good quality packing should have, because that's important to install it without any problems. And also the packing density and tolerances are given, because again, certain density values for packing will make sure that sufficient impregnation is in the packing. Also, in addition, there are certain guidelines given for the packaging and the marking of the products, which is also important to protect the product and when it is stored to make sure that it will maintain its storage time. Some of the packing criteria mentioned in the standard, international standards or guidelines are already in existence. They are all referenced in the document. But then again, we also produced a quite extensive appendix for test procedures that had to be defined to make sure that the quality standards can be met. So the first one is the determination of the grease, oil or binder content, the determination of the size, the determination of the density, and again, the tables shown in the previous slides is the determination of tensile strength and the location at break of packing yarns, the determination of shrinkage of the packing yarns, and the determination of the creep resistance of the packings. They all have been defined in an extensive appendix, and specific methods are given. To sum up, a new guideline to define good quality packing materials as well as packings has been established and approved by E.S.A. and F.S.A. packing division members. It has been forwarded now to CEN as a new work item proposal to establish an EN standard. We hope the proposal will be accepted and we can develop our draft then into a recognized standard which can be used to define good quality packings as well as materials. This brings me to the end of the presentation. I'd like to thank you for your attention. In addition, we have a question and answer sessions where we'll be answering some questions in relation to this presentation.
Ralf, here is your first question. What is the benefit of this standard for the valve OEM or end user?
The benefit of the standards for valve OEMs or end users is that they can be sure that they buy a quality product which is defined in the standard. For example, values like tensile strength, shrinkage, creep relaxation determine how good the performance of the product is and if it will be guaranteeing a longer service life and a good leakage performance, which is important nowadays, especially in regard of fugitive emissions.
Ralf, is the standard only for valve packings?
As mentioned before, the standard is not only for valve packings, but also for pump, mixer, or agitator packings. The difference is the pump or mixer packings have a running-in lubricant, which guarantees that the heat expansion at certain shaft speeds is counteracted, whereas the valve packings only contain an impregnation to make sure that they have a good leakage performance and low creep relaxation.
What is the timeline to see this standard adopted as an official chain standard?
The timeline to see this standard hopefully adopted as an EN standard is quite long, because there are several stages that the standard process has to go through. It will be probably around 3 years. After the initial proposal stage, there's a preparation stage and then a committee stage. Then it will be inquiry stage and it will be voted upon. And if it finally will be approved, there's an approval as well as a publication stage. But we hope in around 3 years that this packing standard will be published.
Ralf, your next question is, Can this standard help to guarantee a longer service life for a packing?
Can this standard guarantee longer service life for packings? I believe so, because again, certain quality criteria that a good packing should have to maintain a long service life, less leakage, are in the standard, as I described before, in regard of the tensile strengths, the shrinkage, creep relaxation, and other quality criteria for the packing products.
Thank you, Ralf, for your good presentation. The time is over.
I'd like to thank you for your attention.
I wish you all a very nice day. Bye bye.